Next part is called compositions of functions. So a composition is a two-step process. It takes the output from one of the functions and plugs it in as the input of the other. So the notation that we use, it kind of looks like it says fog. It's like f with an open dot g. We call it f of g. So f composed of g, if you will. It's more simply put, it's like our former notation where we have f of g of x. So we have g, we plug everything into g of x first, and whatever we get from there, we plug that into f of x. So the domain of f of g of x, so f composed of g, is all the values in x in the domain of g, such that g of x is in the domain of f. So if it's not in the domain of g, it cannot be in the domain of the rest. So let's take a second, see if we can organize this. We're given a couple steps here. So it says f of x equals 2 to the x and g of x equals 7 minus x. We're asked to find f of g of 4. So step 1, it's kind of like order of operations. We're going to start all the way on the inside. Let's start off with finding g of 4. So g of 4 is 7 minus 4. 7 minus x, or in this case 7 minus 4, which is 3. Now we take this number, and plug it in. So g of 4 ends up being 3, so now we plug in 3 into the f function. So it's 2 to the third, which equals 8. So more simply put, if we have f of g of 4, that simplifies to just 8. So again, start off with the innermost function, in this case g, plug it into that, and then whatever number you get from there, that number you plug back in to our function